Hello. In this video, we'll be solving this question. We want to find the domain of this function. Um, in other words, we want to find the values of x for which this is well defined, or for which this function makes sense. So now we will try to avoid some values of x that will make, for example, that will make the numerator, the numerator undefined, or the denominator to make it 0. So we can rewrite this as x plus 3. Then here we can factorize x as a common factor. So you have x squared plus 5x plus 6. And this we can easily write as x, then x plus 2, and x plus 3. So now this is an even root. So we'll try to avoid, we don't want these quantity here, x plus 3, we don't want it to be negative, because if it is negative, you take the even root of a negative number, it's going to be an imaginary number. So to avoid that, we will want our x plus 3 to be greater or equals to 0. Also, we will try to avoid having what? 0 at the denominator. So definitely we don't want x to be 0. And also, we will avoid x to be what? Minus 2. And also, we also avoid x being what? Minus 3. So these are the restrictions that we're going to work with. We want to remove all of this now from, let's say, number line. So let's just go and have a sketch. Now let's put all these values. What this means? This means x should be greater equals to minus 3. So let's say this is minus 3. And what number else do we have here? Minus 2 is somewhere here. And then we have x, sorry, minus 2 should be somewhere here. And then we have what? We have 0. Okay. Now, we want x to be greater equals to minus 3. So this is the first thing here. Let's go this way. We'll keep going to infinity. And this is, let's say this is minus infinity. Now, based on this one, greater equal to, you see there is equality, right? So this is the first uh, values of x. But now we have to remove what? We have to remove x equals to 0. So when we get x equals to 0, we can put a hole around here. So it means x cannot be 0. Also, when we get to minus 2, so at minus 2 also we need to put what? Like a hole. All right. Then we also have another restriction here that x cannot be what? X cannot be minus 3. Though initially here you see there is equality, greater equals to minus 3. So that's why here is closed. But because of this restriction also, we have to open this. So here also is now open. Because if you leave this closed at minus 3, you see you have a problem here at the denominator. Because if x is minus 3, we'll have 0 at the denominator. Okay, I think we're done. So the domain is from where? We now go from minus 3 open to minus 2 open, union. This will be from minus 2 open as well to 0. Then union, we go from 0 to infinity. So for any value of x, you take from this interval, this our function here will make sense, will be well defined. So this is the domain. I hope you enjoyed this video. Thank you for watching.